Hello and welcome. We are at the final stages of day 2 of Innovation 025. It's been a fantastic day. I hope you've all had heard stimulating talks, met wonderful people out in the breakout groups, found out and learned new things, and have most importantly created symbiotic relationships with other people that are going to help you have more impact. Today, this is a very special way to end this, I think. It perhaps is not what you'd expect from an innovation festival, which can sometimes focus on the machines. We're going to take a deep dive into the world of the mycorrhizal network, the fungi, the organisms that change our world and shape our world. And I couldn't think of anyone better to do that with than Merlin Sheldrake, scientist, author, advocate, and person who's brought such passion and entertainment to this subject. So, Merlin, I'm just going to ask can you just give us a very quick explanation of why fungi really are the thing that you're so passionate about?
Thanks, Bryony, and thanks all for staying this long. It's such a beautiful day, and I'm impressed at your stamina, and excited to be here because I really think of fungi as innovators. You know, we can think about the way that humans innovate by creating machines. We can think about the way humans innovate by creating cultural entities and processes, like language, for example. But this is all set within a much longer story of innovation in the history of life. And fungi are key in this longer story, as well as in our present. So fungi are a kingdom of life. And when we think of fungi, we normally think of mushrooms, but fungi spend most of their lives not as mushrooms, but as branching, fusing networks of tubular cells called mycelial networks. And this is one of the reasons this life form, this way of living, this lifestyle is one of the reasons why I'm so interested in them, because they're able to solve complex problems without having a brain. They have remarkable regenerative abilities. You can take a fragment of a network and it can regenerate a whole new network. They embody decentralized information processing, and they underpin many of the most vital processes on the planet. So they are pushing carbon into the soil, they're supporting plant life, they're decomposing all sorts of substances from rock to wood. So without them there would be no world as we know it. And so that's, I think, why I care so much.
Those are a lot of good reasons to be interested in this topic. And as you say, I mean, the fungi have been around for approximately 1 billion years, innovating throughout that time. And the thing that I find hugely humbling is to remember that the natural world has been around for so long and had so much time to develop this toolkit of adaptation. And you go into this in wonderful detail in your book, Entangled Life, which if you haven't read it, you all should. It's now sold over 1 million copies, and it's really captured people's imagination, hasn't it? So how long did that take, and how did you come to write that book?
Oh, it took a few years, maybe 3 years to do. And one of the fun things about this book, I've been studying mycorrhizal fungi, which is a certain type of fungus, a group of fungi that form symbiotic relationships with plants and make plant life possible. This is one of the spheres in which fungi innovate, in terms of radical relationships that change the course of life. By partnering with each other, organisms can do things that neither could do alone, and new biological horizons open up. And plants and mycorrhizal fungi have created one of those whole new waves of possibility, and you act in the play of life, and we're in that act. So I was interested in these fungi, but then I started writing about fungi more generally, and it was a fascinating thing to range across these different departments of fungal life and different departments of human life. From medicine, where fungi are chemically innovating and have been for a long time, and transforming how we think of drugs and drug development and the way we heal our bodies and deal with health. Very important in the agricultural world. Anyone who deals with plants is dealing with fungi that make plant life possible. So I was ranging from the biomedical to the agricultural to the forestry to the soil scientists to the environmental sciences. So the book was that's I think one of the most thrilling things about it was.
But it was also a lovely personal account of your life has kind of almost infused with these with the fungi, hasn't it? From a very young age, and you talk about your father's relationship with some of the leading figures in this world. So it was something that you grew up with almost, wasn't it?
Yes, in some sense, because they're all around us, So in some sense, we're all growing up around fungi. We're all relating to fungi, whether or not we think about it, And I guess I was lucky to have people who reminded me that I was relating to fungi.
And so we're here most of today and yesterday we've been talking about climate change and the need to transition. Why are we innovating? We're innovating because we need to fix some big problems in the world. And one of the things that fungi do is they help store carbon in the soil. So do you want to talk a little bit about that?
Mm-hmm. So in their capacity as the life support system of most of plant life, fungi are vital in taking carbon from plants. So from the atmosphere, plants fix that carbon in the process of photosynthesis. It flows down through plants, and plants feed this carbon to fungi that live in and around their roots. Those fungi, these are mycorrhizal fungi living in and around plant roots. They grow into plant roots like docking stations. Roots in some way are docking stations for fungi. And so these fungi then grow out into the soil. They form their networks in the soil. They forage for nutrients that the plants need, like nitrogen and phosphorus. They transport those nutrients through their networks, and they trade them with plants for carbon in the form of sugars and fats. And that's the carbon that the plants have made in photosynthesis. So what that means is that the plant is fixing carbon from the air, taking that chemical carbon or fixed carbon through its body, pushing it into fungal networks, which are then taking that carbon into the soil. And what they do with it there is they use it to build more of their networks, but they also produce recalcitrant compounds that stick around in the soil. They also produce sticky compounds that hold the soil together. And through their networks, they themselves bind the soil together. So 13 billion tons of carbon enter the soil every year through this route. And it's very important, and we don't think enough about it. So one of the things that I do, I work with an amazing team, an organization called the Society for the Protection of Underground Networks, and we're mapping mycorrhizal fungal communities, and we're identifying threats to these communities, and we're identifying opportunities where we can, conserve parts of underground ecosystems that are responsible for extra amounts of carbon drawdown, or which have other extraordinary capabilities that we can deploy in our fight to save biodiversity and mitigate climate change.
So I might come back to you about that part, the advocate part of what you do, but I think we've got a couple of videos that we can show that actually show the incredible nature of this network and its way of moving things around. So whoever's on the technical desk, if we could show the first video, that would be wonderful.
So this video, this is carbon flowing through a mycorrhizal network in real time. It's important that you notice in real time. This has not been sped up. And the way it changes direction at the junctions, the way that the flow speed differs at different parts of the network. This is a tiny part of a network, right? It's a small moment in a large network. And so it gives you a sense that these are open pipes through which carbon is moving. And we understand a little about how it's moving and how these fungi are able to direct it around their bodies, but direct it they can. And in the next video we're going to see, perhaps we can start the next video. You'll see this blob, the orange blob. That's a blob of carbon, of lipids, moving through this network. It's approaching a Y junction. Now, look at what it does at this Y junction. Again, this is real time. So the blob is going to go up this one branch of the Y. All very well. And now it comes back to that Y, and something happens. It splits and divides itself across that junction. And I wanted to show this because it shows you how these are not just plumbing systems. They are active participants in the way that carbon moves. They're able to divert these chemicals and substances around their bodies, and they're very much agents in the global biogeochemical cycles. And I work in a group, this comes from this amazing lab group that I work with in Amsterdam, and we spend time in dark, and I go there, we look at these videos in darkened rooms, just amazed at the things that these fungi can do. And so just wanted to bring that here to make this more vivid.
Yeah, thank you. So we're getting a sense here how incredible they are, but I wanted to talk about some of the roles in which humans and fungi are already collaborating. And they really are a sort of chemical Swiss Army knife, aren't they? They kind of, that you give them a problem and they'll just sit and work through all of their rule book that they've perhaps tried over the last billion years. And tell us a bit about bioremediation and how they help there.
So fungi are metabolically ingenious. They're chemical wizards, and they're able to break down some of the most stubborn substances on the planet. There are fungi that can, as I mentioned earlier, break down rock, breaking down wood, which is really very difficult to do. We forget how hard it is to break down wood. There are some fungi that live on whiskey that evaporates from whiskey barrels in Canadian distilleries. There are some fungi that live on kerosene in the fuel tanks of aircraft and cause all sorts of mischief there. But so these wildly different appetites, and what that means is that we can partner with fungi who can break certain things down to accomplish metabolic challenges that we're not able to accomplish by ourselves. And we do this all the time when we ferment. For example, alcohol. We invite a fungus, a yeast, to convert sugar into alcohol. We do this in all sorts of fermented foods and other industrial processes. So in bioremediation or mycoremediation, you're inviting a fungus to break something down that you need to be broken down. And there's all sorts of promise here. A good example that I have a friend who did an experiment. He wanted to see if oyster mushrooms could break down used cigarette butts. So he started growing this oyster mushroom on unused cigarette butts, and with 20% unused cigarette butts and the rest grain. When the oyster mushroom got used to the cigarette butts, started to break them down, he gradually phased in more and more cigarette butts until it was living only on cigarette butts. And then he started phasing in used cigarette butts, which are altogether a different challenge because they've got these poisonous polyaromatic hydrocarbons. And it started to get used to those. In the end, it was living solely off the used cigarette butts. And the way we think about it is it's kind of like the fungus has got this deep well of metabolic potential within it, and it's flicking through these, like a jailer flicking through keys, testing each one until it gets and can unlock these chemical bonds. And this fungus, it took a few weeks for it to get used to this new challenge, but it did. And so I think this illustrates some of the ways that we can start to think about partnering with fungi to do some of the things that we don't know how to do.
And what's kind of puzzling people, and this is a great area for unknowns, right? Known unknowns. There are just so many things we don't quite understand. But it seems to have an intelligence, or at least some kind of ability to shape and change things. But it simply doesn't have the structures we're used to, right? So it's kind of causing a rethinking of what does intelligence even mean. A little bit like if we've all watched the Octopus Teacher film, which was such a breakthrough, having to suddenly think, hang on, this is a creature with a brain that's throughout all of its limbs. Here it's an extreme version of that, isn't it? So.
Mm-hmm. Very much so. We just had a paper out a few weeks ago in Nature, and we found that we were studying these mycorrhizal networks with an imaging robot that allowed us to do many years worth, a century's worth of microscopy in 3 years to study the way that they build these networks and how they divert the material around them to solve problems. And it's weird to think of that initially. It's like, well, how are they solving problems without brains? But our brains are made up of fantastically complex networks of electrically excitable cells, and these fungi grow fantastically complex networks of electrically excitable cells and also chemically sensitive cells. And so they're a network problem-solving organism, and I think it can invite us to deepen and expand our understanding of intelligence to take in more of the living world and maybe set aside some of our species narcissism and our cerebrocentrism.
And so also, and really, we are quite late in the day in realizing they need protection, right? Or at least we should be paying more attention to their loss. So, and that's what spurred the creation of SPUN, the Society for the Protection of Underground Networks. It does sound a bit shady, but it's a great acronym. Tell us a little bit about your work at SPUN.
Yes, as I mentioned earlier, we're mapping these the mycorrhizal communities of the planet so that we can better take them into account in our decision making. At the moment, it's a little bit like we're trying to solve a puzzle, but with several missing pieces, vital missing pieces. And in SPUN, the work we're doing there, and with our allies at the Fungi Foundation, we're trying to put some of these missing pieces back on the table so that we can work with them in our efforts to rise to the challenges of our time. So if we have network maps of mycorrhizal fungal communities, then we can start to identify what they're doing, where they're doing it, the ways that they're supporting the biosphere, and the ways that we can work with them to turbocharge our efforts and help restore degraded ecosystems and conserve ecosystems as well. And so we think of them like they're this circulatory system of the planet, and one of the vital life support systems that underlies almost every other aspect of the living world. So it's a lot about making their lives visible. It's about making networks of researchers which can, to study these organisms, to take an interest in the underground, and to start to shift our perspectives a little bit, because it's like we've been floating on the surface of the ocean and studying the life that we can see from the surface of the ocean upwards without ever sticking our heads underneath. And so we're trying to stick our heads underneath the ocean and take account of the many lives that unfold there.
And just practically, is it possible to list an area of land as a protected nature reserve because of its mycorrhizal or its fungi species? Do they have the same status as, say, beetles and plants and butterflies, or how are they treated in the kind of way we regulate?
So this is one of the things we're working on a lot, and together with the Fungi Foundation, because they're not taking that seriously. But this is what we have to do to put the third F, flora, fauna, so plants, animals and plants, and fungi. And it's really vitally important we do this, because if we don't, then all our other efforts to conserve and restore will be sabotaged, because without fungi you can't have these other organisms. So writing fungi into conservation frameworks, writing fungi into the ways, our litanies of protection and conservation is a really vitally important thing that we're working hard on at the moment.
And I think what I love about the way you approach this subject is not just that you're scientifically so deep into this subject that we could talk probably for hours, but you've been able to communicate this in such a fun way. And I have to say, probably the way that you've interacted and brought attention, some of them have been quite amazing. I was just at the Botanical Gardens in Cambridge on Monday, and you famously decided that when you were a student there, I think, that you were going to allow the fungi to enter your consciousness through, was it scrumping Newton's apples? Do you want to tell that story?
Yeah, it was, there's at Cambridge, Isaac Newton was at Cambridge, and there's a famous story about him and how an apple fell on his head and inspired his theory of universal gravitation. And there's all these academics at Cambridge who celebrate Newton, of course, but this story is not, there's no firm basis in fact. It's apocryphal, people say it's a legend, it's a myth. But nonetheless, trees which are taken as cuttings from a very old apple tree that grows outside Newton's family home, these trees have been planted around Cambridge, sort of in celebration of Newton, but also in celebration of this myth. So I was at the Botanical Gardens. I asked the director if I could make some cider from these apples, one of the Newton trees, and he said no. I said why? And he said, well, they had to be seen by tourists to be falling from the tree to add verisimilitude to the myth. So I went at night anyway with a friend, and we took the apples, most of them, we left some on the tree for the tourists, and made cider with these apples, and then this cider was obviously called Gravity, and it was a really enjoyable experience. And then we drank it with a lot of scientists, and there was a way of that our conversations about Newton were different after the cider than they were before the cider. And
And in similar fashion, I think there's a lovely YouTube clip of you giving your book back to the fungi and allowing the fungi to decompose your own book. And then I think, do you eat the mushrooms at the end?
I let the fungus rot my book, and then I let them grow into mushrooms, and then I ate the mushrooms, and in doing so, I ate my words, and because they'd metabolized them. And yeah, it was a way of feeding the book back into the metabolic cycles that it talks about.
Absolutely. Well, listen, and we should also say that there's a film that's just been released recently, which it's in IMAX. And where else can people see it? And what's it called?
It's called Fungi Web of Life. It's in IMAX cinemas, and it's it's narrated by Bjork, and it's got stunning time-lapse by some of the best fungal images in the world at the moment. And so, for me, that's so compelling to see the lives of these organisms on a time scale that you can understand, and on a size which completely overtakes you. And for me, it's perspective shifting in a good way.
Well, listen, it's been an absolute delight to spend this time with you, Merlin, and certainly was a book that changed my perspective on the natural world. And I would, as I say, encourage people to spend some time just putting this challenge that we're facing of transitioning to a cleaner, safer world where we're trying to combat climate change. Just bear in mind where we are in this arc of history and the role that humans have played. It's kind of a blinking of an eye, really. But we are an inventive species. In fact, we are not just a single organism ourselves. We're a collection of species. So, and we're all symbiotic creatures, both within ourselves, how we interact with nature, and we have got this ingenuity imbued within us. So innovation is, I think, our greatest hope, human ingenuity, natural ingenuity, and that's what gives me hope that this is probably a century-long fight that we're in to try and get back to a stable climate or to stabilize our climate, but we're well on the way. And as we learn more, as we are more curious, as we look around the world and find ways of acting together, we'll be stronger. So Merlin, I don't have any final words to leave our audience with.
Well, yes, on that note, actually, I think, I think a lot about, as I've mentioned, that innovation takes place within this realm of relationship a lot, and many of the biggest moments in the history of life have been innovations in relationship, new relationships formed. Often, these relationships are formed at times of crisis. Crisis is a crucible for new symbiotic relationships. So I think at this time of crisis and transformation, I love to think about the ways that we can lean into this relationship building, and this might be relationships with other kinds of human, other humans than oneself, like other centers of human feeling and subjectivity, and it might be relationships between you and animals or plants or microbes or whole different ecological communities. But the way that we think about relationships, I think, will be the key to moving forwards. And so in doing so, we'll be taking a lesson from the long history of life. In doing so, we'll be able to think outside perhaps our limited stories of individualism and isolation, and lean into a much bigger togetherness. So, that's what I like to think about.
Well, thank you, Merlin. This brings us to the end of day 2 of this wonderful conference. I've been delighted to be a participant. I want to say thanks to all the people who've made this possible. Tim Mann and Alistair are here in the audience, I think. It's been a fantastic experience. I really hope that this grows and continues and it helps forge more relationships, and we have more of these types of events. Thank you for being here. Thank you for supporting everyone. And I will now hand back over to our wonderful host, Ariane, and say thank you to you all.
Thank you so much.